Alright then, hello guys. Today we're doing another PicoCTF challenge, and the challenge we're going to be doing today is going to be called Heap 2, which is part of the PicoCTF 2024. So we want to do is first launch our instance and look at the hint. It says, are you doing the right in DNS? So with this challenge, can you handle function pointers? And then connect with the challenge instance right here. So what I did initially was download the files needed to solve this challenge, but I already solved it. So let's go over how I solved it. So initially, when you look at catchow.c, which is one of the things that they give you right away, you see that it has to do with heaps, and we see there's a win function right here. So it asks us to read a flag, and then we have all this use case stuff right here. We have the ability to write to the buffer, print out the menu, and print out the heap currently, and all this other extra stuff. But the thing we want to do right here is to check win for this condition, or I guess we want to be able to do a win. So it says yeah, we want to be able to run the win function. So how do we do that? So if we check the file right now initially, so we do nano solve.py, and then we do from pwn import all, and we do context dot binary equals, and then the name of the binary, which is just chow. So if we do python 3 solve.py, we'll just wait right here. Hopefully it does it. We get information about the binary, which is it's a 64-bit, and it says no canary found, but NX is enabled, and partial railroad, and no pi. So what does NX enable mean? That basically means we can't execute stuff on the stack, but what we could do is redirect. So what we could do is basically redirect our stack pointer to this function right here, and that's what we're gonna do. So how do we do that? So first we want to get some kind of buffer overflow, which we have right here. So we write gdb.chow. We see that we have right here. Now if we do break star main, and now we type run, we see all this stuff being right here. So now we press continue. It says we get all this right here. So it says I have a function I sometimes like to call. Maybe you should change it. So what we want to be able to do is first write to the buffer, then add data to it. And what I'm gonna do is add data by size of 10. So I'll add 10 initial for 10. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 A's. And then just to be sure it's actually 10 A's, we'll just do length of 10 A's. Hopefully it's 10. Yeah, it's 10. So all I'll do is just press enter, and then print out the for print flag, and then we get nothing. 6F, nothing. We weren't able to get a segmentation fault, because if you check the source code, if you press 4, it says does check when. And check when, there's basically, it runs like this weird pointer variable, so I'm guessing, which is causing the whole thing to crash. So what do we do next? We try this again. Run, continue, and then we want to do what? Write to the buffer, and this time we'll put 20 instead. And we'll keep on doing this, seeing if we could get some type of 10, 20. Now we have 20. So now if we press enter, and then do for print flag, we still get a 6F fault, but we don't get we don't see any changes right here. I think from initially, or it's probably like some small changes, but yeah. So it's 962 ends, and this one ends with 962. Yes, no changes. So now if we run this again, continue, and then enter the choice 2, A, 20, 10, 20, 30. Now if we run 4 to print flag, we get nothing so far. Same thing. Now we do this again. Run, continue, to write to the buffer, and then let's just check if my voice is still recording, and it is. So now if we do 1, 2, 3, 4, so now it's 40, and now we press 4. Now we see something different. We see it stopped at 441. That's where it stopped at, because it wasn't able to, I guess, go to this memory address of 441. So what do we do here? See, cannot access memory at 441. So what can we do right here? So we could assume that 4 1 and A is basically 4 1 and hex, so we could take off 4 4s right here. So it's 1 2 3 4. So in our initial payload, continue right to the buffer, and then I did like 1 2 3 4, and I take out 4 of them. 1 2 3 4. Now if I run this and then do 4, we still get this exact same thing. So we need to eliminate 4 of these so we could have full control of what it could access, so we could point it to the win function. So what we'll do again is take out 4 from our initial payload right here. So I'll just copy this, copy it, run, continue, enter choice 2, right to the buffer. How much data? Basically 4 less. So 1 2 3 4, enter, and then 4 print flag. And then we get right here that we get this data right here. And just to be sure, let's just add 1 more A on our initial one that we have right here to be sure that we have full control of it. So now we run, continue, write data to the buffer A, and then we'll just do 1 more. So my theory, we should see a 41 at the end, and we do. So we know it's exactly 1 less than that. So we'll just have that right here. So do length, and then that, and then I think 1 less A, or maybe 1 more. 31. No, it was 1 more. So it was 32, and we added 1 more to make it 33, and then that's why we had extra 40. Oh, we could just grab it right here. Which is this? Length of this is basically 34. So we had to take out 2 of them, and that's why there was 2 A's right here. So how do we solve this? How will we, I guess, go about this challenge? How will we go about this? So what we want to be able to do is basically I want to be able to change the address right here to the win address. So what we could do is do gdb chow, and then we know that, oh, we already have it right here. So exit. So we know cat chow.c. We know that there's already a win function right here to like print out the flag for us. So what we want to be able to do is basically run. Yeah, if we run it, continue, right to the buffer, but to our buffer we're gonna add 32 A's. But at the end of it, we want to point it to the address of win. So how do we get the address of win? Is basically we just do gdb chow, and then this sass win. We basically get this right here. But what we want to be able to do is send that data. So Python. So we'll do from pwn import all, and then we can do p64, and then just go like that, ox, and then we just grab this data right here and just send it at the end. And it might not work because we're not, like, I guess, actually doing it in code. I think it's a lot easier. Like, there's no, like, the data doesn't get messed up at the end of the day if we do it just straight in Python, which I'm about to do right now. But just for this sake, I'll just do it like this. So if I run this, and then if I do for print flag, yeah, we got a segmentation fault because it didn't like really know how to read this correctly. So what I'm gonna be able to do is just write a Python program to, I guess, show this in real life. So what we want to be able to do is first go to exit right here, nano solve.py from pwn context binary chow. So what we'll do is do p equals process, and then what we'll do is put the name of the challenge file, chow, and then what we're gonna do is do payload is gonna equal to a bunch of A's in bytes, and then we're gonna multiply it by 32. And then we're gonna add payload plus equals P64. Reason being because at the beginning we saw it was 64. That was the initial one for the file. And now we'll just delete this, and we'll just put P64, and then we'll just put this right here, this memory address where the win function is at. So we do something like that, close it off. At the end, we'll do send line after, and then we're gonna do enter your choice, because if you run the software exit gdb dot chow, it says enter your choice, and then we're gonna send in our choice, which is 2. Enter your choice, and we're gonna send in the data type of 2, and then we're gonna do p dot send line our payload, and that's gonna fill up the payload. And then after that we'll do p dot send line, and then we're gonna send 4 so we could print out the flag. Send line after, and then enter your choice, and then we're gonna enter our choice, which is 4. And then we're gonna do p dot interactive. So this should basically solve the challenge for us. Hello. And the reason why it printed out hello is because we cat flag.txt, that's what it holds. So now if we just change this to what we want, which is basically not process but remote, which is what we're trying to access, is p equals remote, and then we're just gonna put the remote server that PwnTools gave us, and we only have we have 17 minutes, that's fine. So we just copy this right here, and then 538. I'm not gonna try memorizing that, so we'll just do a question mark right here, quotation, and then we're just gonna wrap this around quotes. And now if we run this, we should get our flag. And we did PicoCTF, and down down the road we go. So we just copy this, insert it right here, and boom, we solved this challenge. So yeah, that's about it. Hope you guys learned something more about, I guess, heap overflow or anything like that. Pretty fun challenge, and hopefully we get these done by this week. But anyway, that's about it. Peace.